Alright, so the previous video went over basics of gas laws, basic abbreviations, basic units of measurement, um, all that stuff. So this video is going to focus on the ideal gas law specifically, mainly because a lot of your calculations for this unit are going to be with the ideal gas law. So let's go. The ideal gas law is pressure times volume equals moles times the gas constant times temperature. So what I want you to do, if you haven't done this, because we've already gone over this, is write down a little chart on the side. Doesn't matter where. I'm going to do it here. So we have pressure. That is in atmospheres. Has to be. That's how it's always calculated. Volume. That is in liters. So, which the abbreviation is just a capital L, but that has to be in liters. N is moles, and then that is just MOL. R is 0.0821 liters times atmospheres divided by moles times kelvins. And then lastly, temperature. So temperature must be in kelvins. If you're using any other unit besides the ones I just gave you, you're wrong. Alright, so how do we convert these? First, I'm going to put 1 atmosphere here. And then we're going to do some equilibrium arrows. So, we have 760 TORR is equal to 1 atmosphere, meaning 1 atmosphere is also equal to that many TORR or torr. Over here we have 760 millimeters of mercury. So that means that 760 millimeters of mercury is equal to 1 atmosphere. Alright, so now that we have everything labeled, I'm going to go over some common ways that this formula is rearranged. So, if I was asking you for, say, find volume, what you would have to do is you divide the pressure out. So then V equals nRT over P. If I said find pressure, you would divide the volume out. So you would divide the volume out. That's going to give you this. P equals nRT over V. They are inversely proportional. If I said find the moles, so moles would be, I'm going to write it down here. You would divide out RT. So N would be equal to PV divided by RT. If I said find temperature, you have PV equals nRT. You would divide NR. So that means T equals PV over NR. If you wanted to find R for some reason, even though you already know it, same thing, you just divide out. So every single piece of this equation can be isolated to figure out what it is. They're all proportional to each other. All of them. So let's go over some practice problems so you can see, how this might be asked. All right. This one looks good. I haven't read it yet, so I'm just randomly pulling these off of the internet so we can have some practice problems. Your homework assignments I'm going to write myself, but anyways. So, when filling a weather balloon with gas, you have to consider that the gas will expand greatly as it rises and pressure decreases. Let's say you put about 10 moles of helium gas into a balloon that can inflate to hold 5,000 liters. Currently, the balloon is not full because of the high pressure on the ground. What is the pressure when the balloon rises to a point where the temperature is negative 10 degrees Celsius and the balloon is completely filled with gas? So let's figure that out. This one isn't an ideal gas law, but we could still figure it out. This one looks like pressure, temperature. This is Gay-Lussac's law. So that would be P1 over T1 equals P2 over T2. Oh wait, no, there is moles in there. Never mind. What am I doing? All right, so PV equals nRT. All right, so N equals 10 moles. We have a volume of 5,000 liters because that's the volume of the container, okay? And then we have a temperature that we have to convert, but we have negative 10.0 degrees Celsius. So let's convert that. And actually, let me cut and paste this so we can go to the next page, and I actually have room to write. All right, so let's convert the temperature, pressure, volume, and then R is always the same. It's 0.0821 liters times atmospheres over moles times kelvins. So we have 4 of the 5 things. That means we can solve this. So first, let's convert temperature to kelvins. Negative 10 degrees Celsius plus 273.15 kelvins equals 263.15 kelvins. So we now have our temperature. So let's solve for pressure. P times 5,000.0 liters equals 10 mole, 0.0821 mole times liters. Sorry, I'm not feeling good today. Liters times atmospheres over moles times Kelvin times 263.15 kelvins. Okay, so the way we're going to solve this is we have to isolate P. So we divide out 5,000. So that's gone, and it's over here. So the reason we use the gas constant is because it allows us to cancel units we don't need. You can think of this equation as being written like this. P equals 10 mole over 1, 0.0821, and then that's still liters times atmospheres over moles times kelvins times 263.15 Kelvin over 1. So over 1. And then this would also be 10 mole over 1. Whatever the 1 is, just a constant. And then we have 5,000.0 liters over 1. So the reason you write it like this is because when you're dividing by a fraction, you're actually multiplying by its reciprocal. So even though this is on the bottom, it's on the top here and top here. This will cancel. Kelvin over 1 is on top of this Kelvin. This Kelvin cancels. This mole's on the bottom of this fraction, meaning it's all on the bottom of this, so it cancels. So we're only left with atmospheres, which is what we are looking for. Now we have to plug this into the calculator. So we're going to have 3 terms on the top, so we need parentheses. 10 times 0.0821 times 263.15. Close the parentheses, and you divide it by 5,000. So that means our pressure is going to be 0.0432 atmospheres. So P equals 0.0432 atmospheres. Let me just double check that I put all the values in right. Yep. So that means our pressure is going to be just this. And that's how you use this equation. Let me see what I'm doing on time. So let's do a few more examples so you guys can kind of get the hang of doing these, because, you know, just seeing one example might not help you with everything. All right, let's go back. No, I'm not going to ask you for any of that. All right, let's do this one. All right. At what temperature would 2.1 moles of nitrogen gas have a pressure of 1.25 atmospheres in a 25 liter tank? So let's write this out. We have N equals 2.10 mole. Pressure is 1.25 atmospheres. We have volume is equal to 25.0 liters. So we're trying to solve for temperature. So R equals 0.0821 liters times atmospheres, mole times Kelvin. All right, so let's write this out. How would we isolate this? Even though I already showed you, you would divide by NR. So that means T equals PV over NR. So let's write this out. I'm going to have to go to a new page. Okay. So let's plug everything in. We have 1.25 atmospheres times 25.0 liters divided by 2.10 mole times 0.0821 liters times atmospheres over moles times kelvins. Okay, so T equals this. Your atmospheres is going to cancel, liters cancels, moles cancels, and we're left with kelvins. So we're going to need parentheses on top and bottom for this. So that means your temperature is going to be 181 kelvins. Sorry. Hang on one second. All right, sorry about that. All right. So that means temperature is going to be 181 kelvins. If you wanted to convert this back to Celsius, you would just minus 273.15 kelvins. So in the calculator, I don't know what that is off the top of my head, but so about negative 92 degrees. So pretty cold. All right. Let's see if we can find another problem. All right, we'll do this one. We'll do 4 and 5, and then that should be enough practice. I'm going to just already go to a new page. So you're going to have this note is going to be kind of long, so it's a lot of information, but it'll be fine. Why I hate when it does that. Okay, so what volume is occupied by 5.03 grams of oxygen at 28 degrees Celsius and a pressure of 0.998 atmospheres? So this one, you're going to have to do a little bit of conversions because it's giving you all the information you need to use the ideal gas law, but it doesn't give it to you in an already converted form. So we have to convert this to moles. O2 equals 16 grams per mole times 2. So it's 32 grams per mole. So if you need a periodic table, you can print one out. You don't have to use the one that I put on Canvas. You can use your own. I don't care. But you're going to need a periodic table when you're doing your tests and your quizzes and your homework. Like, mandatory from here on out, because most of the things on there you're going to be doing conversions like this. I'm not going to be giving you softball questions like these past two, because those have been pretty easy, no conversions. They're going to be more like this. All right, so you have to find out how many moles you have first. So 5.03 grams times 1 mole over 32 grams. So 5.03 divided by 32, that's going to be 0.157 moles ish. So N equals 0.157. Let me clean this up a little bit. That way nobody gets lost when they're reading. I've been told my math is extremely sloppy sometimes. All right, so we have pressure. Luckily, we don't have to convert that. That's 0.98 atm. This is mole. We are trying to find volume. We don't know what that is. R is the same. Okay, and then temperature, we have to convert. So I'm going to label this. So we have 28 degrees Celsius. You have to convert it to kelvins. So that is, I think, 301. Yeah. 301.15 kelvins. I'll double check myself in the calculator. Yeah. All right. So temperature is 301.15 Kelvin. Okay. So let's go and figure out what our volume is going to be. So original equation, PV equals nRT. We're solving for V. Divide the P out. So let's plug everything in. V equals 0.157 mole times 0.0821 liters times atmospheres over mole times Kelvin times 301.15 kelvins divided by 0.998 atm. All right, so let's plug this into the calculator. 0.157 times 0.0821 times 301.15 divided by 0.998. So your answer for your volume is going to be about 3.89 liters. So that was that one. If you ever need to pause these, just go ahead and do that while I know I go a little fast when I'm writing, but anyways, let's do, I have time for about one or two more. So we'll do number 5. And then, okay. All right. So let's label everything that we have. So we're going to have to convert this and this to moles. This one's going to be a 2-step conversion right here. All right. 25 degrees Celsius. Let's do what we have first. We have volume. So we have 212 liters. We don't have pressure because we're calculating the pressure. So pressure is our unknown. We have R is 0.0821 liters times atmospheres over moles times kelvins. All right, so let's calculate the temperature first because that one's easier. 25 plus 273.15 equals 298.15 Kelvin. Whenever you see 25 degrees Celsius, you have 298 kelvins. That's usually the value for room temperature. It's about 70-something degrees. So 298.15 Kelvin. And then we need moles. So first things first is, I don't know this off the top of my head, so let me look at the periodic table real quick where argon is. Argon has a mass of 39.948. So AR equals 39 point, I want to say it was 948 grams per mole. Okay, so we need to convert 23.3 kilograms to grams. So 23.3 kilograms of AR times 1,000 grams over 1 kilogram equals, just moving the decimal place, so you have 23,300 grams. So we have a large amount that we have to convert to moles now. So we're going to take the amount in grams and multiply it by the molar mass. Well, actually divide it, but you're always multiplying by the actual conversion factor. So in the calculator, you're just going to divide the molar mass from the amount of argon that we have. So we have 23,300 grams of argon divided by 39.948. So that's going to mean that we have 583.26 moles. So this one's going to yield us quite a large number with pressure. More than likely. I don't know off the top of my head because that is a large tank, but let's find out. So PV equals nRT. We're calculating for pressure. That means we're dividing the volume out. So P equals 5. Let me do this. Let me move this over so I have room to write all this because these are big numbers. So P equals 583.26 mole AR times 0.0821 liters times atmosphere, mole times Kelvin, times, and then we have 298.15 Kelvin divided by 212 liters. So let's put this in the calculator and see what the pressure is going to be. So I'm going to clear the calculator. So we have 583.26 times 0.821 times 298.15 divided by 212. So that means our pressure is going to be 67.34 atmospheres. So that's quite a bit. That's like having 67 atmospheres on top of you. All right. Let me see what I'm doing on time. All right, so that's pretty much it for this video. In terms of ideal gas law. So, I'm gonna go over partial pressures real quick, because that doesn't take that long. And then we'll be done. I'm gonna draw my famous beakers. Okay, so this beaker has a lid on it. Let's pretend. So alright, so we're just gonna pretend like the lid's airtight. So inside, let's just take away the liquid. We don't even need the liquid in there. But anyways, we have a bunch of gas. We're like red. Remember in the simulation, they were all going different directions. We have light blue. And then we can even have some pink, and let's do green just so it's not clashing too much. Alright, so let's say red has a partial pressure of 0.23 atmospheres. And then light blue has a partial pressure, so this will be P1. Light blue can be P2, and that's got one of 0.03 atmospheres. And then our green can be pressure 3. We don't know. And P total I'll do in dark blue. So P total is going to be 0.47 atmospheres. So to solve this, essentially you're just looking at the relationship. This right here is equal to the sum of all of those. So this is called sigma. It means summation. Sum of P n equals P total. So that means you're going to take 0.47 atmospheres and equal it to 0.23 atmospheres plus 0.03 atmospheres plus X. So let me make some room over here because this is literally like algebra 1. So you have 0.47 atmospheres is equal to 0.26 atmospheres. So plus X. So you just subtract this out. And that means the green is going to be exerting 0.21 atmospheres. So .21 atmospheres. And if you add all three of these up, it should give you 0.47. Let me just double check, 'cause I did all this in my head. So 21 plus 0.23 plus 0.03. Yeah, alright. So that's pretty much partial pressures, or what I'm going to expect of you if I ask a question about it. If there's more, I'll do another video, but for right now, that's all I'm expecting. And that's it for this video. If you have any questions on any of the stuff I went over, please ask. My office hours are listed on Canvas. Go in there and make sure you post a picture of what you're asking so I can quickly answer it. All right, thank you.